Welcome back to the third installment of these BRSN slash Cornell Sports Analytics R tutorial videos. Today we will be covering simple linear regression, the first in a series of videos covering data modeling. Again, these videos are also for anyone interested in learning R using dplyr and sports data in general. So if you are not a Cornell student in either of the previously mentioned clubs, welcome. Glad to have you here. And with that, let's get started by loading in some packages. So we're going to load in some packages that are pretty familiar if you watched any of the first two videos. We have Tidyverse. We have the package NFL readr, the package ggimage, GT, and then finally GT extras. We're actually also going to do, I believe, a GG package, which we may or may not have used before, but we will need it later in the tutorial, which I'll actually, I might as well save for then, so we can actually go back and learn why we are using that package in particular. So, leaving that for later. First off, we are going to create pbp point diff com. I already have it and in my environment because I already did the first few steps to this. I already loaded it in just to test it out. So I am going to type in read.csv, and then I'm going to use the saved file that we have from last time, pbp.diffcom.csv. So pbp.diffcom.csv. And when we load in the read CSV, we get the CSV for pbp.diffcom and can pull it up. Remember, this is what we had last time. Points for, points against, point differential, team logo, ESPN, team word mark, team colors. So now that we have that, we are going to actually load in the schedules for 2023, or the schedule for 2023, pardon, as we load in the 2023 schedules. And we are going to filter game underscore type equals reg in all caps. So now that we have schedules, we can open schedules and see that we have the schedule for every game that happened that season, right? When it happened, all the regular season games. So what we're going to do now is we're going to create two functions. And the first of these functions is going to be called records underscore home. We're going to define that function, and it's going to take in schedules or whatever you feed it. And we're going to take in schedules, this data frame that we've defined, and we are going to group by home team, and we are going to find the wins, losses, and ties for each team. So mutate wins equals some result is greater than 0. Losses equals some result is less than 0, because the result takes the home team, right? Like we said in one of the previous tutorials, the result column is the amount of points the home team wins or loses by. So we are also going to include ties. That's going to be some result equals 0. And now that we will have wins, losses, and ties, we are going to ungroup. And then finally select home team, wins, losses, and ties. And then we want to return something from this function. So we're just going to return schedules itself. And then R automatically closes the function. We're going to do the same thing for away team. So what we can do is just copy and paste this and then change all instances of home to away. So records away, takes in schedules, group by away team, and then select away team, wins, losses, and ties. So we can run these just have them in R. So now these functions are in R. So I can look records home, or records away in this case, and it actually gives you the function. So now it's a function we can use in R. So then we are going to take schedules underscore home. We're going to create that. We're going to take records underscore home of schedules. Remember that function we just made, and we're going to rename the home team column to just team. So when you run this, you get schedules home, which is it has every game because we haven't ran unique on it yet, but it has every team's record at home. And then we are going to do the same thing for schedules away. Just copy this code as well and change every home to an away. So now that we have schedules home, we should have schedules away. Oh, that's schedules home. And here's schedules away. Every team's record away that season. I do believe we ran into some sort of issue here where it was flipping everything. So we take these. Oh, we have to flip the signs. So be careful to flip the signs, right? A loss is if the result is greater than 0. A win is if it's less than 0. That's why I always check my data frames. So now we should have everything that is correct. And we should have Carolina that was 0-9 at home in 2023. They were not 9-0 at home or away, pardon. So now that we have these, we can combine them to find total records. So we're going to R bind them, which we learned before, schedules home and schedules away. And we are going to group by team. We're going to mutate wins equals sum wins. Losses equals sum losses. Ties equals sum ties. And we are going to run unique. And I just realized why we got so many ones of each, or so many like columns or rows, apologies, of each team. We didn't put the unique functions in these functions. So go back, put the unique function within these. So now that we have that as unique, we should only have, once we run these two, 32 observations in each of these. So important step, go back and write unique in each of them. If not, I mean, you can always write unique here as well. Either one works. I think it's just easier to do it within the function, but you don't need unique in both places. You just need it in one of the two places. So now that we have this, we run unique again, because when we run this to find total records, we get a situation where we have 64 observations and 2 observations for each team. We want to run unique again. We're going to run mutate win percentage equals wins plus 0.5 times ties, because this is how they calculate win percentage. Make sure that's in parentheses, divided by, in parentheses, wins plus losses plus ties. So this is the formula for win percentage. Now we're going to always make sure to ungroup after we've grouped by team. So then we should have the total records in the NFL that year. No teams tied. And we have Baltimore with the best record, Carolina with the worst record, and we have their win percentages. So win percentages for every single team. So now that we have that, we are going to join the total records data frame we just made with the play-by-play point differential Tom data frame. So records point diff, total records, should not be capitalized there, total records, left join, PBP point diff Tom, y equals team. So if I bring PBP point diff com over here, they both have the team column, so we can join them by team. We've done this before. You're going to select and get rid of this X column that's been bugging us for a little bit. And then we are going to mutate point diff equals points for minus points against. Oh, it already has that. That's my apologies. In one of the saved ones, it does not contain that point diff column. So this is records point diff. So it has all 32 teams, their records, and their point differential. We're actually going to get rid of x.1 too, and get rid of that column as well, because that's a little bit of an eyesore. So now that we have that, we are going to plot these on technically a geom image plot, but it's technically a dot plot or practically a dot plot for all things considered. I'm going to take records point diff, run ggplot, AES, point diff, X is point diff, and Y is win percentage. Right? We want to plot these to see if point differential can help predict win percentage, but just as the dependent and independent variable. We'll get to why we're doing this later. Geom image AES, image equals team logo ESPN, and we've done something similar to this. Size is 0.04. Aspect ratio is 16/9. So if we run this, it'll take a tiny bit to load, but we should see something come up with point differential and win percentage and the team logos. So while we're doing that, we'll create the labels. So the label for the x-axis is going to be point differential. As you can see, it just popped up over here. The label for the y is going to be win percentage. The title is going to be NFL point differential versus win percentage. And the subtitle is going to be 2023 season, week 1 through 18, data via NFL read R. We're going to add a theme to that as well. So I believe we've explained the theme 538. It just makes it look nice, like 538, if you've heard of it. Then we're going to add specific features, which I believe we've done before as well. Plot title equals element text, because we're editing the text, the element that is the text of the plot title. H just 0.05, 0.5, sorry, to put it in the center. Base equals bold to make our title bold. Size equals 20 to make it larger. Then we have plot.subtitle. We are going to run element text, do nothing to it except H just equals 0.5 and move it to the center of our plot. Axis title Y equals element text. So what this does is, because maybe we haven't used 538, I don't recall, axis dot title dot x equals element text. This just makes sure, because if we run theme 538, and I spelled it 538, so this is why spelling is important. If you just run this here, apologies with this, that would be doing that. Let's see if this works when I run it. It should be working through there. It's because I used a pipe operator instead of a plus sign as we're supposed to do for ggplot. So I will run all of this again, and we will wait a few seconds for it to load. And here it is. Move this over. Might take a few seconds to load once again. Apologies as well. Kind of see it when it stretched out a little bit. Point differential versus win percentage. You can see it's pretty correlated. We have our title, we have our subtitle. Everything's cool with that. So basically, if you just drew a line here, and we wanted to predict point differential based on win percentage using linear regression to the line from win percentage to the point on the line. That's a very simple explanation of what linear regression is. It's so much more than that. I would advise maybe looking up another video that will explain more in depth the theory behind linear regression and more so why specifically we would implement it. But this linear regression is going to be a very simple, linear regression. So we're going to call this win percentage model. And we are going to do LM, which is the function we need to run for linear regression, win percentage based off of point differential. So I really think this is based off of, that's how I think about it. This is the Y, this is the X. Whenever I run this code, I say this as, or I say the tilde is based off of. So win percentage based off of point differential, and then we need to add the data we're taking from, which is records, point diff. And now when we run this model, we can run the summary function. Tell us about the model. So a lot of this stuff, you don't really need to know for these tutorials. You just need to, the estimate is the intercept where it starts out 0.5. That's where it kind of should be, right? 50% win percentage. So for every point in point differential, this is how much the expected win percentage goes up by. That's a little small explanation of linear regression in this case. And if you want a more in-depth explanation, that I'll explain more behind, your R-squareds and your p-values. You probably heard of a p-value if you've taken a stats class. But if you're willing to look more into that, there are definitely a lot of tutorials available online that will go more into depth about linear regression. So now that we have our linear regression model, we are going to use the predict function to add the predictions to a new data frame. So records point diff. I'll type it out because you'll have to probably type it out as well because it won't already be in your global environment. We're going to take records point diff. We are going to mutate, create a new column. This first column is going to be expected win percentage. Apologies. And we are going to predict win percentage model. So we're going to use the win percentage model to predict win probabilities, or not win probabilities, sorry. WP a lot of the time in a lot of data frames is win probability. Win percentage based off of the win percentage model. So if actually we just run this, right, and open this data frame, we should see an expected win percentage that uses the point differential. So now that we have an expected win percentage and an actual win percentage, we can take the difference and we can say win percentage over expected is equal to win percentage minus expected win percentage using only point differential. So this is a very simple linear regression, as I said before. Obviously, there are so many factors that go into, calculating an expected winning percentage, but, we're keeping it simple for the sake of this video, just to introduce you guys to linear regression. So we are going to round expected win percentage times 17 to get, the expected number of games, and then we are going to round the number. So if we just do this, this should be a minus. There we go. We just do this. We get expected wins because I did do the round function. So we're not going to do the round function. And expected wins, they have so many decimals. So to undo that, we are going to do the round function and then comma 1. And what that does is that does it to 1 decimal. So we're going to do expected wins with 1 decimal place just to make the data look cleaner. So the highest expected wins, Baltimore. The lowest expected wins, Washington, not Carolina. So now that we have that, we can do now wins over expected. And we're going to round WOPOE. itself times 17, then add that 1. We're going to run this. So remember, win percentage over expected, we're going to take the win percentage over expected and then turn that into a number of wins. So wins over expected. Philadelphia had the highest wins over expected, and the lowest wins over expected was the Chargers, which they had 2.2 wins under expected. Opposite of over is under right there. So now that we have that, we are going to redo the graph from earlier, and we are going to add a regression line. So what we're going to do here is we are going to completely copy and paste this. Just be careful of what you are looking at when you copy and paste. So we are going to change this, right, the thing we're plotting, to this new data frame. So make sure to change it to this new data frame. Take this and move it down here. So to create a line through it, like I was talking before, we're going to do geom smooth. We're going to use the method linear regression. So this will give us our linear regression line. And the color we'll make black. And we don't want confidence interval there. Geom segment. AS X equals point diff. These are just going to be lines from the points to the regression line to kind of show you how the regression kind of works. Win percentage, and then the X end is apologies, is going to be point diff, and the Y end is going to be expected WP, which will be along the line of linear regression. You'll see in a second. Then what else we're going to do? We're going to make that color, the color of these segments, gray, and the line type dashed. Now that we have this, we can run it as well. It says geom smooth smoothing must be created by, it's because we put the F in parentheses, in quotation marks. That's one of the issues. Potentially looking at another issue here. Let's see if I can. Oh, it's because we put it after the ggplot, guys. Make sure to put the ggplot first. You initialize the ggplot by putting a ggplot first, and it's giving us line type dashed should be in quotation marks, and there we go. We're finally getting our graph working, and it should take a second to load in. Once it loads in, I can show you the regression line and the line segments connecting the regression line. So the black line is the regression line, and each team dribbles down or up to the regression line to the predicted win percentage based on point differential. So think of this line as Y predicted on X, right? We're going to add one more thing while we expand that. We are going to annotate. We're going to include a text annotation, X equals -150, just to put it all the way over here. And we're going to put it in the top left corner. Y is 0.075. Label, and we are going to label the R squared from earlier, which will tell us sort of pretty well how this data relates to itself, the variability of Y predicted by X, but it tells us in a way how good our data predicts on each other. It's very simple at doing that. It's not the best way to tell, absolutely not the best way to tell, but it's more advanced learning Y than we'll get into, and there are definitely other great ways to visualize it, this relationship and how good it is, but this is just kind of a simple one that people sometimes use. So now we have point differential versus win percentage. As you can see, the Ravens, the 49ers, the Cowboys, they actually won fewer games than they predicted. We can go in here and we can see Baltimore, 0.5 fewer. Dallas, 1.3 fewer. San Francisco, 1.2 fewer. So now that we have that, we are going to make, an expected wins versus actual wins plot, which will kind of be similar. So we are going to do records, point, diff, predicted. We're going to do ggplot, AES, and I'm typing this out this time because it's a lot easier to, especially if you're creating like a whole new plot with new variables, just to type things out again. It helps with your memory as well. Geom image, AES, you always need that for geom image. Image equals team logo ESPN, size equals 0.03, aspect 16/9, labs, y equals wins, x equals wins, apologies, y equals expected wins. This is just another way to visualize what we've created here. Title equals wins versus expected wins. Our subtitle is going to equal 2023 season week 1 to 18 or 1 through 18. Apologies there. And then data via NFL read R. We're going to choose a different theme here. It's going to be themes black and white, which we've used before. XLim, we're going to go 1 to 14. These are just to change the limits of the X and Y axis. I can show you what happens if we don't. It's just easier to include this. And we're going to include, I'm going to copy and paste the themes because it'll take a little bit to write them out. We're going to use the same themes. We're going to move the plot to the middle, make it bold, make it size 20. We're going to move the subtitle to the middle. And then technically we don't need those two, so we can just get rid of them. We're going to include a line here. So we're going to do geom ab line, which is different from geom smooth. If you're doing geom smooth, it's usually a regression line and you can implement regression on it. We're going to say slope is 1, intercept is 0, and this line is just going to go through the plot to show which teams have a greater expected wins than they do wins. Color equals black, and the line type is going to equal dashed. So when you run this, it will take a second to run, but we will be able to see expected wins versus wins. Actually make it bigger and see, okay, it did load, but unfortunately it loaded right after the fact that I chose to make it bigger. And once it loads, wins versus expected wins. And we have this line going through, right? So the Ravens had a greater number of expected wins than wins, which was, we said earlier, shown by their wins over expected being 0.5, right? Their wins were 13. Their expected wins were a little higher at 13.5. And then I'll make it a little bit smaller if you want to take another look at it and see where your team was in 2023. But also, again, a simple linear regression model. Not really going to tell you much, but it's just good practice to do it and good to get you guys started thinking about linear regressions like this. And that actually concludes this workshop. So thank you for watching. I almost forgot to save, so we're going to call this, I know you can't see this, but you can call it whatever you want. I'm going to call it Learning R Tutorial 3. And it pops up here. Don't forget to save. Don't forget to title it. Don't forget to make sure you're working in the working directory that you want to be working in. And yeah, that'll do it. And thank you guys again for watching. And I hope you all have a great day.